Hello, third grade friends. Welcome to your geometry lesson today on the different types of trapezoids. As a reminder, this is what a trapezoid looks like. This is probably the type of trapezoid that you have seen the most, and we find this in our quadrilateral drawer. So a trapezoid has 4 sides, and it has a minor base and a major base. So we have one base that is shorter and one base that is longer. So this is just our normal trapezoid that we usually see. But there are actually 4 types of trapezoids that we are going to look at today. The first type of trapezoid is called an isosceles trapezoid. So you may remember that the word isosceles means that there are 2 sides that are the exact same length. So on an isosceles trapezoid, we have these 2 sides that are the same length, and then we still have our minor base and our major base. So first we have our isosceles trapezoid. Then here we have our scalene trapezoid. You might remember that scalene means that none of the sides are the same length. So in our isosceles trapezoid, there are 2 sides that are the same length. In our scalene trapezoid, none of these sides would be the same length. If we were to get out a ruler, we would see that none of them were the same. So we call that type of a trapezoid a scalene trapezoid. The other 2 types of trapezoids, we're going to be focusing on the angles, not on the sides. So here we have what's called an obtuse trapezoid. We know that this is an obtuse trapezoid because there is an obtuse angle inside of the trapezoid. Remember that the word obtuse means that it is greater than 90 degrees or it is larger than a right angle. So we see here, this is an obtuse trapezoid. Our last type of trapezoid is called a right trapezoid. We know that because it has a right angle. And we know that a right angle is equal to 90 degrees. Now, you might be thinking, how will I know if the angle is obtuse or if it's right? Sometimes it's kind of hard to tell. So I'm going to review with you how we use our protractor. Y'all see Sunny in the background? She's chewing on a bone on the couch right now. So I'm going to review with you how we would use a protractor to measure this. So if we didn't know if this was an obtuse trapezoid, we would first get out our protractor. This is what we use to measure angles. And we always measure angles in degrees. We know that a full circle is 360 degrees. So we can think about how large this angle would be. If this is a full circle, that's only a small part of that circle. So first what you do is you want to line up, and I'm going to show you this in just a moment, your vertex to the little open circle that's on your protractor. So you can see here, that little open circle right here is right on the vertex of the angle. And then that straight line, see how right now it's not right lined up with the bottom line? I'm going to move it up so that it is. Okay? Then what we're going to do is we are just going to follow our finger up the opposite angle side, and we can see that this angle is 120 degrees. 120 is greater than 90, so we know that this would be an obtuse angle because it is larger than 90 degrees. Just like here, when we're measuring our other angle, we have to line up the dot to be on the vertex, make sure that my bottom line's lined up, trace the line up to the top, and it is exactly 90 degrees. Let's say, just for fun, we wanted to measure the length or the amount that this angle is. How many degrees is this angle? So I'm going to do the same thing. I'm going to line up the open circle to the vertex. Make sure that that line is lined up with the bottom side of the angle. Follow the other side up, my finger's covering it, and it would be 70 degrees, which is smaller than 90 degrees, which is called an acute angle. So as a review, we learned about our isosceles trapezoid, our scalene trapezoid, our obtuse trapezoid, and our right trapezoid. Have a wonderful rest of your day, and we will see you soon.